Now, before I discuss the harness, let me introduce you to someone. Meet Fred. Fred is an agent. Fred is enthusiastic, and he wants to get things done. Right now, Fred is trying to complete a complex multi-hour task for you. But Fred has a problem. Actually, he has several problems. One, he declares victory too early. About 20% of the way through, he will generate a confident-sounding conclusion. Assume he's done and stop. He's not lazy. He believes he finished. And two, he forgets things. His context window, that's the max amount of tokens he can stuff into his brain at a time, is easily packed with intermediate work, old tool outputs, half-finished plans. His reasoning gets fuzzy, and we call this context rot. His brain fills up, and he cannot think straight. 3. Even the right tools, and these can include access to third-party applications like the user's browser, the user's file manager, the user's email. Fred can delete files, send emails, or update databases, and sometimes he does so enthusiastically without asking. Fred is not a bad agent. He's just incomplete. He's an agent without a harness. So what's a harness? A harness is the software infrastructure that wraps around a model, handling everything except the model itself. In practical terms, the harness connects an AI model to the outside world, enabling it to safely deliver tools, remember context between steps, and interact with complex environments. So why can't we use the model alone? Because models by themselves are stateless. Every new session starts blind. They have no inherent persistence, no built-in safety, and no way to recover from failure. The full agent, therefore, is model plus harness is equal to agent. One of the most important patterns inside the harness is a Ralph Wiggum loop. Yes, named after the Simpsons character who keeps doing something long after he should stop. In the context of AI, the Ralph loop is a mechanism that prevents an agent from quitting too early. It intercepts the moment Fred tries to declare victory, and instead of letting him stop, it lets him start with a clean context window and pick up where he left off. More specifically, the harness starts as a fresh instance of Fred with a completely clean context window and re-injects the original goal. Now you might be thinking, won't Fred do the same work all over again? No, because his previous work has been saved. While Fred was working, the harness was quietly persisting his progress to a file system. His to-do list, his completed steps, his partial outputs. So when new Fred spins up, he reads those files, sees exactly what has been done, and continues right where previous Fred left off. This pattern solves two of Fred's problems. 1, early stopping, and 2, context rot. So we have Fred, we have a harness, we have a harness pattern, the Ralph loop, and now let's put them together. Let's start building piece by piece. We will start with the environment because before we give Fred any capabilities, we have to make sure he can't break anything. The first thing we give Fred is a sandbox. When Fred needs to run potentially risky code, he doesn't do it directly on the host. Instead, the harness hands that work off to a sandbox, an isolated environment like Docker, Modal, or Runloop. Think of it this way. Fred is a craftsman. The sandbox is a sealed, isolated space where he can safely run experiments without setting his shop on fire. When he needs to perform a risky operation, he reaches into the sandbox with a tool that's analogous to a robotic arm that does the work in the sandbox, keeping him and his shop safe. Next, we give Fred a file system as working memory. Every time Fred completes a step, he records his progress. In a framework like LangGraph, we can even add checkpoints. If Fred's progress crashes at 3 a.m., the harness does not throw up its hand. It resumes Fred from the last checkpoint exactly where he left off. No lost work, no starting over. Now Fred can run for hours, even days, without losing his place or breaking production. But Fred is still easily distracted. Give him a complex goal and he gets confused. So we add reasoning and orchestration logic. We need a way to break down big tasks into subtasks, coordinate work across steps, and manage dependencies. Instead of having Fred do all the work, have him supervise a team of sub-agents. Perhaps match sub-agents with smaller models, both less costly and a smaller carbon footprint. And we can also add context engineering. Remember context rot? Well, this is how we fight it. We use summarization to condense Fred's history when his context window gets too large. We load instructions only as needed, using something called skills, and offload subtask-specific context to sub-agents. Agents don't need to carry the entire instruction manual in their head. They just need the right context at the right time, in the right size, in the right format, for the right task. Now Fred has tools. He has a sandbox, he has memory, he has orchestration, and he's powerful. And that's exactly when things get dangerous. So we add governance, guardrails that define what Fred can and cannot do. Maybe he can read files, but not write to production. Maybe he can send emails, but only to internal addresses. These are deterministic boundaries written into the infrastructure, not suggestions in a prompt. And because this all has cost, we add budget and cost management. The harness tracks Fred's token usage and estimated costs. If Fred gets enthusiastic and starts burning through budget, the harness can intercept tool calls or pause execution before the bill spirals out of control. But what about gray areas? The decisions we cannot predefine. That's where human in the loop comes in. When Fred tries to make a high-stakes or ambiguous tool call like deleting a database, the harness flags the action for a human. The human can approve, edit, or reject it before anything happens. And at this point, Fred has improved tremendously, but when something goes wrong, and something will go wrong, we need to know why. So we add observability, logging, and tracing that captures exactly what Fred did, when, and why. When Fred misbehaves, we don't guess, we read the logs. And finally, we add verification. This is the self-correcting loop. We add measurable success metrics every time Fred completes a task. We compare his output against those metrics. If he succeeded, great. If he failed, the harness feeds that info back so future Fred gets better. So that's Fred. By the time we're done, Fred is not just a lone agent, he's one wrapped in a harness ready to take off. We gave him a sandbox to execute code, a file system for memory, reasoning and orchestration to keep him and his team focused, guardrails to keep everyone safe, observability to understand what he did, and verification as part of a self-improving loop. So let's come back to where we started. There is a huge gap between pilot and production. Every wasted token has a cost: financial, environmental, and human. The organizations that succeed with agentic AI will not be ones with the flashiest demos. They'll be the ones who realize that a well-designed harness with humans in the loop is both the most reliable path to production and the most responsible, greenest way to build. Less waste, fewer failed runs, and humans where they belong. Thank you for listening.